kids are there to solve math?
Many!
Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solving perimeter is?
2 times length plus 2 times width.
Good afternoon and welcome to the elementary version of Count on Us. I'm Shari Sternberg.
And I am Janita Jenneret, your host for the day.
And we are excited to be here with you, and we hope that you're excited to be here with us as you are getting those homework problems ready to give us a call. Our number is 301-772-0080. That's one way to reach us, but there are several others.
Yes, you can email us at COW, that stands for Count on Us, COU at pgcps.org. And we're on channel 96 on Comcast and channel 38 on the Verizon. And we are back. I'm back. My first show of the new year.
All right, and we're back also from the beginning of the week. We had some issues going on with the phones and with some of the technology, but we are back, so make sure you give us a call. We are here live, ready to take your calls. And while you're getting your homework ready, and while you are calling us, or emailing us, or streaming us live on the computer, we're going to share with you some of our challenges. We have our infamous Challenge 24.
Woohoo, my favorite.
All right.
I'm going to go over each of the cards and the digits. You can write the digits down.
Write them down.
We're going to start with card A. The digits are 9, 1, 8, and 6. Card B is 8, 7, 2, 2. Card C, we have 2, 9, 6, 1. And card D, we have 9, 4, 8, and 4. Remember, with the 24 challenge, you want to use all the digits on each card one time and one time only. You can use a combination of addition, subtraction, multiplication, or division. And the goal is to come up with 24.
And please remember, you need to have the Challenge 24 solved before you give us a call.
Yes.
Okay, so don't call us and work it out online while you're live with us. Work it out and then give us a call. We also have another challenge, and I'm going to put my hand up here and say things that make you go, So here's what we want to know. What shape has the greatest perimeter? So you might want to jot these down so you can do some calculations. The first one says a square that has 4 centimeter sides. The second one, a pentagon that has 3 centimeter sides. Third option, a hexagon that has 2 centimeter sides. And our last option, an octagon that has 1 centimeter side. So, if you're not sure how many sides each of these shapes have, hey, use your math book, use your brain, phone a friend, use the internet, do whatever it takes to figure out what shapes we're referring to, and then do the calculation and let us know, if you can figure that one out.
That one is I love that one.
All right, so I always love to give them some strategies for Challenge 24.
Okay.
And some of the strategies, first recommendation is to just add all 4 numbers. Mm-hmm. Add them up, see if they come to 24, and if they do, obviously you have an answer right then and there. Mm-hmm. But have a second solution. Every card, I have not hit one card yet that only has one solution.
Neither.
Every card has at least 2. Some cards I've found 3, and believe it or not, there's been a few I've found 4 different solutions to these cards. So find at least 1 or 2 solutions and work on those. One of the strategies, and there are some students out there who can, I'm good at Challenge 24, but they can put me to shame because you put that card down and they are slapping. And it's all because of patterns and factors. Patterns and factors. So At this point, our students should be experts at this because I show this all the time. The teachers that I work with, they all know the Texas T because when I show that off, factors of 24, we learn those, you memorize those, you will be better off not only with the Challenge 24, but 4th, 5th graders and above, all of your math will be helped by knowing the Texas T, how to find factors, and especially by memorizing the factors of 24. So let's go to it. Texas T, you put a 24 on the top, any number that you want to find the factors of. All right, we're going to do 24. And every number, whether prime or composite, starts with a 1 and itself. So no matter what number we put here, we're always going to start with the first counting number. And when you count, you always count by saying 1, 2, 3. So 1 is the first counting number. You put that up, and then you put the number that multiplies to give us the number above the Texas T. Okay, so that's what we're looking for. We're always looking for this number to be the 24. Next counting number is?
2.
2. So I'm going to put 2 on this side, and we're going to think, what number times 2 is going to give us 24?
Well, I do know that 24 is an even number, and I know that all even numbers are divisible by 2. So what I can do, a good strategy, is to skip count, and I'm going to skip count by 2s, and I know I can get to 24 when I count 12 times.
12
so 2
times.
times 12.
Excellent, okay? And again, we're using the divisibility rules because our 4 here in the ones place is an even number. We know that all even numbers are divisible by 2. So again, we're showing you there's our 24 that is again on top of our Texas T. Next counting number is?
3.
3. So we're just counting using our counting numbers. 3 times what number? Notice as we're getting bigger here, we're getting smaller here. So we're going to need a number smaller than 12. And we're thinking algebraically, what number times 3 is going to give us that 24? And we know our basic facts, so we're going to say
8.
8.
Another divisibility rule for 24 as well. If I add 2 and 4, that equals 6. And since I know that 6 is a factor of 3, then 24 is also divisible by 3.
All right, so we'll use our divisibility rules as we go to the next counting number, which is 4. What number times 4 is going to give us that 24?
I will say to myself, 4 times what? 4 times 6. And the divisibility rule for 24, the last digit is, help me out. It's 4 and 8s. 4 and 8s have the same divisibility rule. So we're just going to stick with the algebraic.
Exactly.
4 times what equals 24, and I do know that's 6.
And we also know that 4 is double 2, even number, and that gets us there as well.
Very good.
Okay. And we also know that if there were 2 12s, double 2 cut 12 in half. Okay, so looking at multiple strategies. Again, getting bigger on one side as we get smaller on the other because we're taking smaller groups, more groups, but smaller in each group. And then our next counting number is
5.
Now, divisibility rule right here.
I know that rule. The last digit, if it's divisible by 5, must be a 0 or a 5.
Which it is not.
So I know that 5 is because this is a great strategy. I never heard of the Texas T, but I love it because it makes you go through all the numbers and just use those divisibility rules.
Exactly.
And when I don't have it,
you cross it out, you're done. So now the next counting number is
6.
6. Now here's where our students have a problem, and we just have to remember this step. I have some students who then write 6, 7, 8, 9, and keep going. But 6 is the next counting number. We already have 6.
Yes.
Tells us we're done. All right? So now what we do is we circle our pairs. We know these are partners. We know these are factors that get us to 24. Anything with an X without a partner is not a factor of 24. And then typically what we do is we just write them out. And usually, again, however your teacher tells you to do it, but often you see them from least to greatest, and they're already set up for you that way in this kind of horseshoe. So we have 1, 2, 3, 4, move to the other side, 6, 8, 12, and 24 are all factors of 24.
That's why 24 is such a cool number.
Oh,
Look at all those
numbers.
factors.
Excellent. Now, if we take these numbers, and you know what? Did we have another card here? I was going to maybe do a different one and not give away an answer to one of these, but
You know,
we don't.
it's
Okay,
gone.
well let's use one of these because we do know that some of these have 2 answers. So we're going to say, let's take the 2, 9, 6, and 1. What we like to do, first of all, I'm going to add 9 plus 1 is 10. And again, I could add 9 plus 2 is 11 plus 6 is 17, 18, but I like to put together friendly numbers, and 9 and 1 makes it 10, that's friendly, plus 6 more is 16, plus 2 is 18. 18 doesn't equal 24, so by just adding them, I'm not getting there. So now I'm thinking about my factors of 24. And I know 6 is a factor of 24, so now I'm saying to myself, what's its partner? Well, I know 6 and 4. Is there something I can do with these numbers to get to a 4? I've got a 9, a 2, and a 1. And I'm actually seeing something already, because I know if I take 1 from 9, I get 8. And 2 and 8 together are going to give me a 4. Okay, so watch. Here's what I'm going to say. 9 minus 1 equals 8. And actually, 9 and 1 is 8, and then 8's partner is 3. I'm also seeing a 3.
Because I saw 2 ways. That's why I
Okay,
love this
so
game.
now we're seeing more ways. But let me finish my train of thought. 9, take away 1. I use the 9 and the 1. I wanted to get to a 4, which is the partner factor of 6 to get to 24. I know if I take 8 and I divide it by 2, I'm going to get my 4. And then 4 times the 6 that I have left is going to give me my 24. So I'm going to ring the bell for myself. Yay! All right, now, Ms. Generette said that she sees another way.
I do. I thought I did, because when you initially started, we started with the 6, and we know 6 has a partner to make 24, which is 4. So I was looking at the 2 and the 9 and the 1 to see if I can get a 4, and I think I made a mistake, but I'm going to check and see if that is correct. 9 and 2, if I subtract, that'll give me 7. Nothing with 7 and 1 will give me a 4. 2 and 1 is 3, nothing with 3 and 9. It'll give me a 6, which is a factor of 24, but I need a 4. So I'm going to have to restructure my strategy. Yes, 6 would be a good number to start with, but I need a 4, and there's no way that I can get to a 4. I also see a 12. 6 times 2 is 12. 12 has a partner of 2. 9 and 1, I already know automatically. There's no 2 that I'm going to get out of 9 and 1. So the 2 and the 6 multiplied together will not work. So I'd made a mistake before. This right here looks like the one solution that I can find. I know there's more.
And you know what? I'm going to jump right in here just for 1 second where you said you made a mistake. You're doing some trial and error, checking, guessing, thinking out loud. You're using strategies. I don't call that a mistake. I tell my students all the time, we want to persevere.
Yes.
Okay, we don't want to give up. We want to make sure we keep working. So we found one solution. I already kind of hinted at another, because 6 and 2
I see it now.
give us another number. I gave you an 8. What's 8's partner? Think through that. We're going to go to the phone lines and take a call right now, and then we're going to come back and talk more about this.
Yes, yes, yes. We have Trevor from TAYAC. Hi, Trevor.
Hi.
I see you have a multiplication question.
Yeah.
Okay, Trevor. What's your question?
Can I just ask Trevor what grade you're in so we can kind of focus our problem?
5th.
5th grade, and you're working on multiplication. All right, cool, Trevor.
Okay, Trevor. What's your question?
162
162
times 24.
All right.
24, our challenge number.
Woo. You know, the one thing I love to do when I have any kind of algorithm to do, I want to get an estimate. So let's look at 162. I want to make nice, easy numbers that I can do mentally. 162, Trevor, is closest to which 100?
200.
200. Woo, it's hard to write this way. And 24, I want a nice round number, so I want a 0 at the end. So what 10 is 24 closest to?
30.
Well, I think it's more closer to 20.
Oh, yeah, 20.
Good, good, good. It's almost, if it was 25, I would go ahead with 30, but let's go ahead and make it 20.
Okay.
Okay, Trevor, can you tell me mentally what 200 times 20 is?
4,000.
Very good. See how well we did that? I bet you thought, I can't do that in my head. So this estimate right here will let us know that our answer should be around 4,000. Now I'm going to ask you one more question.
Yes.
You know what? I'm going to skip that question. Let's go ahead, because it might throw us off a little bit. So whatever our answer should be close to 4,000. So let's go with our original numbers, 162 times 24. There are several different ways we can do this. We have the lattice method. We have the partial products method. Let's do the method where we start off with the ones and multiply each digit in 162. Is that good, Trevor?
Okay.
All right. We always start in the ones place when we do it the traditional method. 4 times 2.
8.
Very good. 4 times 2 is 8. Now, we say 4 times 6, but this really isn't 6, is it?
No.
The 6 is in what place?
The 10s.
Tens place. So we're actually doing 4 times 60, but just because our numbers are here, let's go ahead. 4 times 6.
24.
24. Now, we are regrouping. Since the answer is truly 240, we know all of the tens cannot fit here, so we're going to regroup. We're going to put the 4 in the tens place, put the 2 in the hundreds place, and we're going to move on. 4 times 1.
4.
4, and then we had to add the 2 that we brought to the hundreds place. What's 4?
6.
Excellent job. Perfect. Now, I really want to stress place value because we have this lovely 0. Some people don't really know why that 0 is there. The reason why we put that 0 there, because we're no longer dealing with the ones place in the number 24. We're moving on to the
10s place.
Very good. So really, technically, we're doing 20 times 2, 20 times 60, and 20 times 100. But let's just go with our digits that we see right here. We're in the tens place. What's 2 times 2?
4.
Very good. Now we're going to go 2 times 6.
12.
12. We cannot put all 12 hundreds in the hundreds place. I'm going to cross this 2 up here off. And we're going to regroup and put our 1 in the hundreds place. So now we're at 2 times 1.
2.
2 plus 1.
3.
3. And you know what? I'm going to show you why this estimate is so fabulous. Now we have our partial products. We have 648 plus 3,240. We're going to add those together. We can start in the ones place. What's 8 plus 0?
8.
8 plus 8. I'm sorry, so sorry. 4 plus 4. I just gave you the answer.
8.
Thank you. What's 6 plus 2?
8.
And 3, nothing there, so we can just bring down the 3. So what is our final product?
3,888.
Now, is this number close to our estimate?
Yes.
It is. So this estimate also shows whether or not our answer is reasonable, and it is. And I was going to make a mistake prior. For some reason in my head, I had 2 times 1, and I forgot to add this 1 up here. So if I would have had the 2 here, and then my answer would have been 2,888, would that answer have been close to my estimate?
It would have been over it, but a little.
It would have been too far from 4,000. So that's why it's really, really, really important that we do this estimation so we can find out if our answer is reasonable. Now that I see the error that I had initially made, this answer is much closer to 4,000, so this is a reasonable answer. Very good, Trevor.
Thank you.
Any questions?
No.
All right, Trevor. We did put your name.
Here it
We
is.
will put your name in our treasure chest.
First name, you have a very high probability of being a winner at this point, Trevor.
Yay!
What percentage, what chance of winning do you have right now if there's one name in the box and we pull one name out of the box? What percentage chance do you have of winning?
100%.
You got it. Fifth grade. I love it.
Yes, yes, yes. Thank you, Trevor.
And actually, right before you started with Trevor, you mentioned some other kind of strategies and which one should he use. Why don't we show some other strategies for multiplying some larger numbers? You mentioned the lattice method.
Mm-hmm.
And lattice method is when you kind of show each number and the place value. So we can write, and you usually write one down the side and one across the bottom?
Yes. And usually, I can tell you that I'm not an expert at the lattice method because I like the traditional. So I've seen it where it's a rectangle. So let me see how you do it, then we can discuss.
All right. Well, if we
what else
do
fit.
162 and we do it times 24, and I just wasn't sure if we should put the three. It might be easier to put the 3 digits on the top.
Yeah.
Let's try the 162 times the 24. And what this does is it kind of maps out each place and its value. When Miss Generette was doing the problem with Trevor, she was mentioning we're saying 2, but it's really a 20. It's really in the tens place. Well, this kind of maps out so you're seeing each place value. So when we multiply the 2 times the 1, we're actually in the hundreds place. So here's a 2. 2 times 6 is 12. And this is one of the reasons why the lattice method is a little confusing, because we're kind of writing the numbers. We add the numbers on the diagonal. Or am I doing that wrong? And then 2 times 2 is 4. When we go across, we're adding each number. Now, actually, I think I have to bring that 12 over here and bring that extra 1 here. That's what it is. And then we add them on the diagonal. So let's do that again. It's 12, and we have a 1 we have to bring to the next column.
Okay.
And then we have 4 times 2 is 8. 6 times 4 is 24. And we have a 2. And then 4 is 1 is 6. Is that going to get me there? 8, 8.
I see the 3.
8, 8, and 3. Yep, it is going to get me there. All right, so
Yep.
then the thing about lattice is you just add them on the diagonal. So you're taking these diagonal numbers together. So here we have, this one gives us an 8. This gives us, right here, 4 and 4 is 8. 6 and 2 is 8. And 3 and 1 is
2 and 1.
3 and 1. 2 and 1 is 3.
Yep.
And that's what we got.
Same answer. So 2.
So, again, we both kind of use the traditional method more often, but this is another strategy where you're multiplying single digits and you're not getting those partial products. You're getting partial products, but you're getting each place value, and then you add them on the diagonal, and you get the same answer.
Yes.
Okay, so that's another strategy for multiplying larger numbers. Hopefully, the smaller numbers, your strategy is that you know your multiplication.
Yes. And that's like a big thing.
Big thing.
Third
Fifth graders,
grade,
fourth
boom,
graders,
boom, boom.
third graders. All right, we have a call, so we're going to go right to the phone lines, and we're going to help Joseph. And hi, Joseph. This is Count on Us.
Hello?
What grade are you in? Is this Joseph?
Yeah.
What grade are you in, Joseph?
5th grade.
Fifth grade at what school?
Cherokee Lane.
Cherokee
All
Lane.
right,
We
I
get lots
know
of Cherokee
Cherokee
Lane
Lane.
callers, and we appreciate that very much. And can we help you with what? A division problem?
Yes.
All right. Tell us what numbers.
34 divided by 501.
34 divided by 501. So this is what you said to me. Is this what you mean?
No, other way.
All right, and I knew you meant it the other way, but I write it this way because I want students to understand when you say the number divided by, and some people call it inside the house, but whatever number you say first, and if we wrote it the other way, it would look like this, 34 divided by 501. It's not that this problem can't be solved. We don't typically do these type of problems in 5th grade. It just means if you had $34 and you were divvying it up or dividing it between, say, 501 people, they'd each get a little bit, okay? So we can divide smaller numbers by bigger numbers, but typically in 5th grade, that's not what you're doing. So tell me the problem again, Joseph.
501 divided by 34.
You got it. 501 divided by 34. So we should be thinking, how many groups of 34 can we pull out of 501? Now, again, talking about multiple strategies, what strategy do you use or does your teacher want you to use when you solve long division problems of this sort? How do you go about starting the problem?
34 times 1.
Okay, and that's certainly one strategy, and then we do 34 times 2, and then we're at 60, and then times 3, and whoo, we'd be here for a long time.
Yes.
Okay, so the first thing that I like to have my students do is kind of look at that little estimation piece of, if you kind of look at just the front end, just look at the one digit. If we look at this as a 3, and we look here at this as a 50, how many 3s are in 50? Or even start with just the 5. How many 3s are in 5? How many 3s are there in 5? Just 1, okay? That helps us get our first number. And as Miss Generette said in the beginning when she thought she made that mistake, it's okay to do what we call trial and error. Try something if it doesn't work. So because there's only 1, 3, and 5, I'm going to go with it. There's only 134 in 50. And again, this isn't really 50, it's 500, but that's where we're going to start, okay? So we're going to know that 2 digits obviously can't go into just the 5, so there'll be no digit above the 5. Our first digit will be above the 0, and we must have a digit above each number. So we'll have a 2-digit, well, you know what you call the answer in division? Do you know what the vocabulary term? What did you call it?
What, the quotient?
The quotient, excellent.
Yay.
So we're going to have at least a 2-digit quotient, depending on if your class uses remainders or if you find the fraction answer or decimal part of the answer, we'll have a different rest of the answer. So let's start with, we're going to try that 1. And we should already know that, how much is 2 30s? 30 times 2?
32.
No, not 30 plus 2, but 30 times 2. How much are 2 30s? How much is 30 times 2?
60.
60. We know 60 is bigger than 50, so your 1 is actually a very good number to start with. All right, so then we use that strategy. Again, people use that dad, mom, sister, brother, the family, whatever helps you get there. We're going to next, I like putting this X here because then it reminds me the next step is to multiply. So how much is 1 times 34?
34.
Sure, anything times 1 is that other number. And now we're going to subtract 50 minus 34.
Hold
And if you want, we can do that regrouping part and we can trade, but right away we should see that this is going to be a 10, and 4 plus what number is 10? All right, let's go through the steps.
6.
Exactly,
Good
okay?
job.
5th graders, we want to kind of get to the point where we're being a little more efficient than having to go over here and say 5, the 5 becomes 4, this becomes 10. We kind of want to do some of these steps in our head, but 10 minus 4, you just told me was 6. 4 minus 3 is?
4 minus 3 is 2.
Do it again.
1.
Just 1, sure. We do that little check. We make sure 16 is less than 34. If the number we have here is bigger, then we know we could take out another set, and then this would have been a higher number in our quotient. All right, next step is to use our brother and bring down that next digit. Okay? And again, if we use just this first number, it gets us in the ballpark. How many 3s would be in 16? So 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is?
5.
3 times 4?
3 times 4 equals 12.
Okay, so I'm getting closer. What's 3 times 5?
3 times 5 equals 15.
15. Now 5 is closer, but I also have to remember that I'm going to multiply that 5 times this 4 and have 2 extra. So 15 plus 2 is going to be 17. So we have an option. We can try the 5, nothing wrong with that, and then come back. We can do it over here in our workspace. 34 times 5, but you can kind of see what I was saying. 5 times 4 is 20, and then 5 times 3 is 15, plus 2 more is going to give us 17. So the 5 is going to be too big, okay? So what number is 1 less than 5?
4.
4. So we're going to use our 4. Great. All right, so now we're going to multiply 4 times 34. How much is 4 times 4?
16.
Excellent. We have to remember that 1, okay? 4 times 3, you already told me was?
4 times 3 equals 12.
12, plus that 1 makes 13. Now let's do that subtraction part and see what we have left. Again, we're going to do some regrouping. The 6 becomes a 5, and now we have 11. 11 minus 6?
11 minus 6. 5.
Exactly. And if the subtraction part is hard, count up. 6 up to 11 gives you 5. 5 minus 3?
2.
2. 1 minus 1 is 0, so we're not going to put anything there. We have 25 left. We're going to check. Again, it's less than 34, so we're correct. And now, what does your teacher have you do with what's left? Does it become a remainder with the R? Does it become a fraction over our divisor, or does it become a decimal?
Remainder.
Just a remainder. Oh, I was hoping you said
I
decimal.
know, I love decimals.
Plus, by 5th grade, you should be using this as a decimal. You should start doing those. But we'll bring that up here. And do you use a capital R or a small r?
Small r.
Small r. All right. So we'll put that small r, and that becomes 25. So Joseph, this is our quotient, which you told us, Quotient. It's good that we use our math vocabulary. And now, Ms. Generette, you want to take him through checking it?
Yes, I love the checking part. I'm so glad we're going to do that. Since our quotient is 14 remainder 25, what I'm going to do is take the 14 and multiply that with the 34, because the opposite of division is
Multiplication.
very
got it.
good. So
Inverse
division
operations.
can be undone with multiplication. So we're going to multiply. 4 times 4.
Equals 16.
Excellent. We're going to regroup, put the 1 in the tens place. 4 times 3
12.
plus 1.
13.
Excellent job. Have to put my 0 in the placeholder because now I'm moving on to the tens place. 1 times 4.
4.
Good. 1 times 3.
3.
Very good. Now I have my partial products. I'm going to add them up. 6 plus 0.
6.
3 plus 4.
7.
1 plus 3.
4.
Now.
Uh-oh, that doesn't look like what we started with.
Yes.
You
Now.
have to add the remainder.
Joseph. I love it. So I have 476. I have a remainder, so this is the extra, or the leftovers, as my third graders like to call them. 6 plus 5.
6 plus 5 equals 11.
Very good. If you know 5 plus 5, one more, that'll be 11. 1 plus 7?
Huh?
Well, we can do it this way. I started off with what I regrouped, so let's do this way. I see 7 plus 2. What's 7 plus 2?
8.
Try again.
8.
Now he's adding your 1.
Oh, okay, so 1 plus 7 is 8. 8 plus 2 is 10. I had to regroup. I have a 1 now over the hundreds place. 1 plus 4 is?
5.
Very good, Joseph.
Now I feel like we match.
Now my answer matches my dividend, so I know that my quotient is correct.
Excellent. Excellent job, Joseph. And you definitely seem confident with your multiplication facts, so you should be just as confident with your division because it's just that inverse operation. And I know the older kids don't like us saying fact families because the little kids learn the fact families. But if you know your multiplication facts, you know your division facts. So be more confident with those. Your name is getting folded and going into our treasure chest. So right now we have 2 names in our treasure chest. Joseph, what chance do you have of being picked as a winner if there are 2 names inside?
Aww.
Our last caller, when there was 1, he had a 100% chance of winning. He was the only.
50%.
You got it. 50%.
Yay, good job, Joseph.
And on that note, we're going to take a break.
Alrighty.
So what we'd like you to do is, again, work on those Challenge 24s, work on those homework problems, check out our PSAs, the public service announcements that are coming up, and we'll be right back.
Hi, I'm Cameron from Samuel Ogle Middle School. Today's email question is from Nicole at Benjamin Tasker. Nicole says, my problem is 98 hundredths times 7 3/10. I don't know where to put the decimal after I multiply. Help! Well, Nicole, first you do basic multiplication. You do 8 times 3, which equals 24. You drop your 4 and carry your 2. Next you do 3 times 9, which is 27, plus 2 is 29. You drop your 9 and carry your 2. Next you do 3 times 0, which is 0, plus 2 is 2. Next we move to the ones column. Now we do 7 times 8, which equals 56. You drop your 6 and carry your 5. Next we do 7 times 9, 7 times 9 is 63. Plus 5 is 68. You drop your 8 and carry your 6. Next, we do 7 times 0, which equals 0. Plus 6 is 6. So now we add. For a placeholder, we add a 0. 4 plus 0 is 4. 9 plus 6 is 15. Drop your 5, carry your 1. Next we do 8 plus 2. 8 plus 2 is 10, plus 1 is 11. You drop your 1, you carry your 1. Next we do 1 plus 6. 1 plus 6 is 7. Now we look at the problem. We see that a decimal comes before 3 numbers in this problem, which means in the answer, you bring the decimal over 3 places, and you get an answer of 7 and 154 thousandths. Well, Nicole, I hope that was helpful. That was the email question of the day, and I'm Cameron Jenkins from Samuel Ogle. Bye.
Soccer. All across America, it's how kids get fit and have fun. Join us. Go to usyouthsoccer.org.
Welcome back to Count on Us, where you are the stars of the show. You call in, ask us a question, try to stump us.
Our number, 301-772-0080. We are looking forward to hearing from you. We are ready to help you. And we have someone who needs some help right on the line right now.
Yes. Is this Joseph?
Same
Joseph?
Oh, okay. I think it is.
Hi, Joseph.
Hello?
He's back.
We see that you have a question.
Hello?
Hi, Joseph. Can you hear us?
Hello?
Joseph, this is Count on Us. Can you hear us?
Yes, I can hear you.
You can hear
Okay.
me. I'm not sure. Go ahead, talk again.
Can you hear me? Joseph?
Can you hear Miss Generette?
Huh?
I
don't know.
Can you hear Miss Generette when she's talking?
Oh, Joseph, don't listen to us on the TV. Turn your TV down and listen to us through the phone, okay?
Okay.
Okay, good. I think you hear me now. All right, Joseph. It says you have a question with subtracting fractions. What grade are you in?
He's fifth. Cherokee Lane Joseph.
Great. Is this
She
the
has
same?
a short-term memory.
Well, you sound different. Is this the same, Joseph?
Well, he's matured in the last 2 minutes or so. Come on.
That voice got deeper. Okay, Joseph. What's your question?
My question is 9 minus 3/4.
9 minus 3/4.
Oh.
That's a fun one. You know why it's so fun? Joseph?
Tell us why it's so fun.
Because it's a whole number subtracting a fraction. So we have this nice, lovely whole number, and we're just going to take a piece. So we know our answer is going to be around what? What's approximately what our answer should be about? 3/4 is close to which whole number? If we had a number line like Ms. Sternberg has drawn for us,
That's a 1.
where would 3/4 lie?
3/4 is closest to 1.
It's closest to 1.
Tell us now that we're asking, what would this mark represent? What mark would be right in the middle of 1 and 0?
5.
Well, not 5.
0.5.
Well, not 0.5 either.
Right, because we don't say point, so we want you to say, what's another way of saying 0.5? It's what, 5?
5/5.
No, we don't want you to change the number. We want the 5. We just want you to say this 0.5 as you would read it, not just 0.5.
What place is the digit 5 in?
If this was money, how much money would this be?
$5.05.
Oh, no, we're
Well-
going to work on that here.
So 5 is in the tenths.
5/10.
Yay! You redeemed yourself, Joseph.
And if I write it, I can write 5/10 like that as a fraction. And an equivalent fraction of 5/10 would be 1/2. Okay?
So you did say 3/4 was closest to 1. We know 9 take away 1 is what?
8.
8. So we know our answer is going to be about
About 8.
So if we get 6, if we get 4, if we get 2, we know that answer is crazy. So let's go on to subtracting our fraction.
I'll share my eraser.
Oh, thank you. So we have 9 minus 3/4. Apples and oranges. We have a whole number and we have a fraction. Do you know what we can do with 9 so that we have a fraction or a mixed number? I'm going to show you. Give me a fraction that equals a whole number with a denominator of 4.
Give you a fraction that equals what?
1. I'm going to write it here for you. Do you see it? I want a fraction that has a denominator of 4, but it's equivalent to 1.
4/4.
Perfect job. So what I'm going to do with this 9, I'm going to take out a whole and make it a fraction. So if I have 9 and I take out a whole, what would that give me? 9 minus 1. We said it earlier. What's 9 minus 1?
8.
8. But I still want 9. So I'm not going to get rid of that 1 we took out. I'm going to make it a fraction. So I'm going to put it here. So what I did was rename 9, and I named it 8 4/4.
So these two are equivalent. They're equal to each other, same amount.
You understand that? Do you understand how we got to 8 4/4, Joseph?
Joseph, we need you to tell us if you got it or you're with us.
No, not really.
Okay, what we did, we wanted to make an equivalent mixed number to 9, because 9 is just a whole number. Nothing wrong with 9. But I wanted to have a mixed number, so I have a fraction with the same denominator. 9, I can rename 9, and its equivalent mixed number is 8 4/4, because I know 4/4 equals what?
1 whole.
1 whole. 1 whole plus 8 equals
9.
9. So that's why 9 equals 8 4/4. Now I'm going to show you why I did that in a moment, so maybe it'll make it a little clearer. I did that so when I do 8 4/4 minus 3/4, I know when I subtract fractions, do I do anything with the denominators?
No.
No. Since my denominators are the same, I look at the numerators. I can start with my whole number. I have an 8 here. Do I have a whole number with the 3/4? There's no whole number with the 3/4, so I just basically am doing 8 minus 0.
And 8 1/4?
Oh my goodness, you did it so fast. How did you get 8 1/4, Joseph? What did you do?
By subtracting the two numerators.
Very good. We have 4/4 and 3/4. 4/4 minus 3/4 equals, just messed that all up, 1/4. I can add it up to see if I'm right, because my original problem, it's still here, 9 minus 3/4. I just renamed 9 to 8 4/4. 9 minus 3/4 equals 8 1/4. What's the opposite of subtraction? What's the inverse operation to subtraction?
Addition.
Very good. So I can check my subtraction problem with addition. So I'm going to take my answer, 8 1/4, and I'm going to add 3/4. 8 1/4 plus 3/4 gives us
8 1/4 plus 3/4 gives us.
I like how you said it again. That's a good strategy.
8 4/4.
Very good. And what's another name for 8 4/4?
9 4/4.
Not 9 4/4.
Oh, just 9?
Just 9, because remember the 4/4 is a whole, and we're going to put that whole with the 8, make that 9. There's my 9, there's my 9. I checked it. I am done.
You get that, Joseph?
Yeah, I got that.
All right, well, you're not going anywhere yet. You're going to get a private tutoring session today.
I love it.
We are now going to do another problem. We do have your name, so we're going to let Miss Generette fold that one up, and we're going to come right back and do another problem right here. Same strategy. Now we just want to make sure you can apply it, okay? Because you're a little hesitant on some parts here. You have the whole number 7, and you want to take away 2/5. Can we take 2/5 from a whole number? Could you take?
No.
No. So what did you have to do to the 9 so that we could subtract a fraction from it? You had to make what? Do you know what you had to do? All right, we had to make
Subtract 1?
We had to make an equivalent fraction by
Good.
taking 1 away. Exactly. So if we take 1 from 7, how much do we have?
6.
6. And then we want to take that 1 that we just took away and make it into a fraction that we know has fifths in the denominator. So here's our fifths in the denominator. What has to be in our numerator to make that fraction equal 1?
5/5.
Exactly.
Good job.
Same numerator and denominator always equals 1. I actually like to put a 1 around it. It helps us remember. So here we have 6 plus 1, but the 1 is just being called 5/5. Now we can do our regular subtraction. We have like denominators. We have a whole number and no number here. So let's do this problem. The whole number is 6 minus 0. How much is 6 minus 0?
6 3/5.
All right, and we love it. You did the same thing earlier. We ask you one part and you do the whole thing in your head, and that's fine. We like mathematicians to be efficient, so 6 3/5, excellent. And we're going to check it. The inverse of subtraction is?
Addition.
Addition, so we're going to add back in this 2/5, and actually we'll put it underneath like you did here. So we still have our whole number 6, and we have 3/5 plus 2/5, which is?
5/5.
5/5. Soon as we see a numerator and denominator that is the same, it becomes 1. And how much is 6 plus 1?
7.
7, and that tracks us right back to where we started. So actually, you're a little hesitant, but you really do have it, okay? I think maybe if this was a BCR and you had to write out your explanation, you might be a little rough around the edges on some of the writing, but you certainly have the math component of what you have to do each time. You're going to take from the whole number, you're going to make an equivalent fraction so that you'll have like denominators. We could have made another fraction. We could have made 4/4, and then what we would have had to go through more steps to make it an equivalent fraction, common denominators, okay? So you want to do it again. Efficiency is the easiest, most accurate way to solve the problem, okay?
Okay.
Great job, Joseph. We have last question for you before we let you go. We're working you to death here, but you put his name in?
I did.
So, Joseph, your name is now in twice, okay? And there are 3 names inside. Now what is your chance of being picked out of our treasure chest?
75%.
Whoa, give yourself a little too much.
Did you say 25%?
Well, how much did you say? hearing myself echoing in the back again.
75%?
Oh, you said 35%.
No, I think you said 75.
Oh.
So there are 3 names in there, and you are 2 out of the 3. And 2 out of 3 is a fraction. Do you know how to make a fraction into a percent? Sometimes I like my students to just kind of memorize some of these percentages. If you divide by 100, how many times does 3 go into 100? Do you know that percent? And, all right, we're going to make you work then. So this fraction, actually, even though it's a fraction, it says 2 divided by 3. Did you know that, Joseph? Now he's not going to answer me because he doesn't want to do more math.
No.
Okay. Well, yes, that's exactly what it means. Just like this. 1/2 means 1 divided by 2. And how much is 1/2? What percent is 1/2? 1 out of 2. If you have half a dollar, how much do you have?
50%?
Right, 50%. Well, look how we get that. We say 1 divided by 2. And what that looks like is 1 divided by 2. Now, if you have $1 and 2 people, are each of you going to get $1?
No.
No. So what we do when we're dividing by a number that's smaller than when our dividend is smaller than our divisor, what we end up doing is we add a decimal point and 2 zeros. Now it looks just like our dollar, right? And we remember to bring our decimal point back up here, and then I bring out my New York, and I say, and then we forget about it. All right? We just forget about the decimal point. Now, we know that 2 can't, and now we don't even think about it down here anymore. So now we're looking at this. Are there any 2's in 1? Nope. How about 2 and 10? What number times 2 is going to give us 10?
5.
5. 5 times 2 is 10. We subtract, we get 0. We're going to bring down the 0, and because we brought it down, we actually need to bring it up. And look, there's our 50% or our 50 hundredths, which is the same as 50%.
5 cents and 1/2. It's
Exactly.
all connected.
So, now, Miss Jenneret's going to take you through this one.
Yes, so division. A fraction is division. So, 2 divided by 3 is what this fraction means. Are you with me, Joseph?
Yes, I'm with you.
So, we said that since 2, the dividend is smaller than our divisor, what are we going to do to this 2? We're going to add something, you remember?
Put the decimal?
Yep.
And, always and.
And 2 zeros.
Exactly.
And 2 zeros. And then we're going to go up, put our decimal here.
And we're going to forget about it.
Get out of there. So we know 3 can't go into 2. How many 3's go into 20? Here's where we need our... Oh,
6? Good.
Good job. You know this. Okay. So I'm going to put my 6 here. Let me put an X there because we didn't do anything with that 2. What's 6 times 3?
6 times 3 equals 18.
18.
And he has his multiplication facts down.
Oh, yes, he does. Now, I don't want to regroup because I know 18 plus 2 is 20. So I know 20 take away 18 is 2. Bring down that 0.
Oh, it's a 20 again.
Oh, Lordy. What are we going to do? 20 divided by 3. How many 3's are in 20?
Put the 3.
Say it again.
Put the 3.
Are we going to put 3 here? We had a 20 here at the beginning, and we put a 6 here because we can take 6 3's out of 20. 6 times 3 is 18. We subtract, bring down the 0. We have a 20 again, so what digit needs to come up here?
6.
Very good, because it's the same 20. And then, look what this happens.
Boy, you are just repeating yourself.
Ooh, I could do this all day long.
Hopefully you won't.
I won't because I'm going to stop. We can round this. It depends. 6,600. So I'm just going to stop there because we only just wanted to add the 2 zeros. So, last answer. We have 50 hundredths. 50 hundredths equaled what percent? 50 out of half. So what percent? 50 hundredths is 50%.
50%.
Because as soon as you say the number in terms of 100, the number in the numerator is your percent.
And a percent is a number out of 100. It tells us already 50%. So you have 2 names in our box. There are 3 names altogether. So your fraction is 2/3. What percent chance do you have of getting picked out of this treasure chest? We did the division. We ended up with 66 hundredths.
Come on, Joseph.
What percent? What's your percentage?
66%.
Yes. So
That's
you
a large
have
percent.
a 66% chance, 66, 67, because we can round. It's not one of those crazy numbers. So you have a better than 50% chance.
My money's on Joseph at this point because we're ending the show very shortly. We got a couple more things to do. So, Joseph, certainly stay tuned. You certainly worked the hardest today.
You sure did,
So we want to
Joseph.
make sure you stay with us. But you see how all this math is
Thank you.
connected. You're welcome.
You're welcome. You sound excited. I'm excited for you.
But I love the way all this is connected. When I teach my students fractions, especially the 5th graders, fractions, decimals, and percents. If you know one, you know the other. You should be able to take a table, and we leave some blanks along the way in all the different columns, and we're able to do all of these because if we know one, we know all 3 of those.
It's just a beautiful thing. I just love it.
All right. We have enough time, actually, then, to go back and show one more strategy for multiplication.
Yes.
So let us do that. I thought I
there we
started
go.
somewhere, but here we go. All right, we showed you the standard or partial product strategy, which is the typical strategy that we learn in school, but we are not saying that anyone has to do anything anyway. Nowadays, it's any strategy that works every time, and that you can use and explain is a strategy, okay? Reasonable answers. Explanations. You have to be able to communicate it for it to be able to work, okay? So you can't say this I solved the problem this way and it only works on this one problem this one time. It has to work all the time and you have to be able to explain it, all right? So partial products work and lattice method works, and here's a third method. We had 162 times 24. All right. If we take the expanded notation version, so 162 is 100 plus 60 plus 2.
Yes.
And then we take the expanded notation here of 20 plus 4. Make it into a grid. And this method doesn't have the confusing angle way of adding them all up at the end. We just are going to add the numbers. So, and these are all friendly basic facts with extra zeros. So we're going to do this really quick. 2, let's start with the 4. 4 times 100 is 400. 4 times 6 is 24 with a 0, so 240. And 4 times 2 is 8. 20 times 100, it's 2 times 1, which is 2, and 1, 2, 3 zeros.
2,000. Okay.
1, 2, 3 zeros. Did I say that? Yeah. And then 2 times 6 is 12 with 2 zeros. And 2 times 20 is 4 with 1 0. Now we're going to add up our columns. We have 48, we have 1,440, and we have 2,400. Okay, and we're going to add these last 3 numbers together. Here we go on a clean sheet. 240,144. While I'm doing this, you want to shake up that box and get ready to see who's going to win?
Yes. I have a
add these up. We got an 8. We have an 8. We have an 8, and we have a 3 for 3,888, which was the solution we had earlier. Point being, if you like basic facts with zeros and addition more than that multiplication of partial products, this is the way to go.
Okay.
All right, let's see if Joseph, with his 66-point-something chance of winning, is our winner.
And he is.
Makes sense.
Good job, Joseph.
Congratulations to you. We want to thank you for calling Count on Us. We didn't have that many callers, but we had good in-depth problems that we worked on today.
We did a lot of math today. It was fabulous.
Count on Us is coming on again from 5 to 6 o'clock for our middle school students in pre-algebra, so start calling in. We had problems with the phones on Monday, but we are back live, so start calling in right now. And remember, for Miss Generate and myself, you can always count on us.
I'm Miss Frank, and I'm here with today's mini lesson on elapsed time. Elapsed time is when we find the difference between the start time and end time of an event. such as a game, a movie, a race. So I'm going to work on one-word problem with you and show you how I would solve it, and hopefully that will help you solve elapsed time problems in the future. So let's take a look at a problem. This problem is about my friend named Melanie. Melanie was going to the movies. She went to a movie that started at 10:30 a.m. So I'm going to go ahead and I'm going to write down the start time. 10:30 a.m. The movie was 3.5 hours, and we want to find out what time the movie finished. So what we're going to do is we're going to start with our start time, and then we're going to count on the hours first. When we're finished counting on the hours, we're going to then switch to counting on the minutes, which is often what I like to do with elapsed time. Start by counting on hours until we can't add on any more hours, and then we switch to minutes. So let's take a look, and we're going to use a clock, and I preset the clock to 10:30 so that we were ready to go. So let's take a look. We're going to start at 10:30, and we're going to add on 3 more hours, and then we'll worry about the minutes later. So we're starting at 10:30. 1 more hour gets us to 11:30. 1 more hour gets us to 12:30. And then our third and final hour brings us to 1:30. So let's go ahead and write that out on our problem, and that way we can see exactly what we just did on the clock. So we were starting at 10:30 a.m., and 1 more hour brought us to 11:30 a.m. So that's our first hour. Then we went from 11:30 a.m. to 12:30 p.m. and that was our second hour. Notice how I went from a.m. and p.m. because we were at 11:30 a.m. So the next hour would actually be 12:30 p.m. So be very careful to look at your a.m. and p.m. when you're working out a problem to see if somewhere in your problem you're switching between a.m. and p.m. Be very careful. We then went from 12:30 p.m. and we added on our third hour, and that brought us to 1:30 p.m. So there, we added on our 3 hours. We then need to go back and add on our half hour. Since an hour is 60 minutes, then a half hour is 30 minutes. So let's go back to our clock and add on 30 minutes. So we are here at 1:30 p.m. So let's count by fives and add on our 30 minutes. 5, 10, 15, 20, 25. There's our 30 minutes, brings us to 2 o'clock. So let's show that on our problem. And we were at 1:30 p.m. And then our half hour brought us, to 2 o'clock p.m. And that was our 30 minutes. So let's take a look. We added on our 1, 2, 3 hours and 30 minutes, and that brought us to 2 o'clock p.m. So Melanie's movie ended at 2 o'clock p.m. So whenever you're working on elapsed time, remember to start by counting on your hours until you can't add on hours anymore, and then switch to adding on your minutes. And that will hopefully help you find elapsed time in the future. If you don't have a clock at home like I had here, you can always draw one on a piece of paper. Start by drawing a circle, put your 12, your 6, your 3, and your 9, put the other hours in between, and then at least you'll have a visual that will hopefully help you add on your hours and your minutes for elapsed time. Thank you so much, and stay tuned for some more Count on Us. Have a great afternoon.
Across America, Service Learning is helping students improve their grades and their communities. Service Learning makes school exciting by connecting the classroom with community service projects.
Before Service Learning, I was just an ordinary student causing mischief during class. After Service Learning started, I got so involved into it, I started paying attention more, picked up my grades.
Okay, very good.
Service Learning absolutely drives academic success.
Working together, students solve real problems, build new skills, and apply their knowledge in a whole new way.
The great thing about Service Learning is it gives you this opportunity to go out into the world and do things hands-on.
Inside the classroom and out, Service Learning opens new doors and brings learning to life. Service Learning can make a difference in your school. Visit Learn and Serve America at learnandserve.gov to find out how.
Because how many ways are there to solve math?
Many! Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solving perimeter is
2 times width plus 2 times width.
And welcome to your Tully Award-winning math homework hotline. Count on us. Welcome to another exciting math homework hotline episode.
And Happy New Year.
I am Mrs. Davis, and Happy New Year, Miss
McCants.
We're here to help you with any math homework questions you may be having. So if you're stuck on that math problem, you're not quite sure what to do, give us a call. The number is 301-772-0080. Our phone lines are wide open and waiting, so give us a call now. And once you've given us a call, if you would like to challenge yourself, we have the 24 challenge. Card A, this is a 6. This is a 9, so shaded in red is 9. 6, 9, 1, 8. And the way that the challenge works, you're going to use each of these numbers so that you come up with a total of 24. You can add, subtract, multiply, or divide as long as the total is 24. And card B, 2, 8, 7, 2. Card C, 1, 2, 9, 6. Card D, 4, 9, 4, 8. And so you may challenge yourself with these 24 challenges. And the challenge is to get a total of 24. And if you want to make yourself go, things that make you go, what shape has the greatest perimeter? A square that has 4 centimeter sides, a pentagon that has 3 centimeter sides, a hexagon that has 2 centimeter sides, or an octagon that has 1 centimeter sides. And with problem solving, drawing a picture,
yes,
or a diagram
definitely help you.
Would help you to come to a solution. So, without any further ado, we really appreciate all of our callers that have been waiting so patiently.
Yes.
Our frequent fans who tune in every Monday and Wednesday. We really, really appreciate you. And we know that all middle schools in Prince George's County are wild and wonderful.
Yes.
And we're waiting to give your middle school a shout out. So give us a call now at 301-772-0080.
Yes.
All right, and we do have a caller. Caller, thank you for being so patient. Caller, are you there?
Yes.
Hi, welcome to Count on Us. And could I have your name, please?
Trevor.
Hi, Trevor.
Hi, Trevor.
Welcome to Count on Us. So nice of you to call today. And which school are you representing?
Gwen Park Middle School.
Gwen Park Middle School. Come on, ring that bell. Ring that bell. Okay, yes.
Trevor.
All right.
Representing Stephen.
Not Stephen Decatur.
Oh, not Stephen.
Not Stephen Decatur.
Oh, okay.
Gwynn Park Middle School. Yes.
Okay, I'm sorry. I got a little twisted
Yeah,
for a second.
just a second.
All right, Trevor. How can we help you this afternoon?
I'm solving equations.
You're solving an equation. All right.
So
do you have a particular equation?
I'm sorry, Miss Dave.
I'm sorry.
Yes. It is 5x plus 3
5x plus 3
equals 18.
equals 18. Okay, Miss McCants. Solving equations.
Yes, solving equations.
Trevor, do you know what it means to solve an equation?
Aren't we solving for the x?
And does the x have a particular name?
The variable.
Okay,
right.
excellent job.
Very good.
Excellent job.
So we are solving for the variable. And in this equation, the variable is an x. But could it be any other alphabet?
Yes.
It could be any alphabet you want it to be, based upon what the unknown in this problem is representing. All right, Trevor, what do you know about solving equations?
I know that I have to get the x by itself.
Okay, you definitely have to get the x by itself. And there's a particular name that we use when we get the x by itself. It starts with an I. Are you familiar with that I math term?
No.
Okay. When you get something by itself, it's all alone, like on an island. It is isolated. So if we want to isolate this variable, I've already put it in a box like it has chicken pox. What do I need to do to get it all by itself?
Divide by 5.
Okay. Well, before I can divide by 5, I have it in the box right now. So I have to get everything that is not here inside the box away from it on the opposite side of the equal sign. So what do I have that's not with the 5x, with the variable? That's
plus 3.
That's 3. Now, if I'm adding 3, if I'd like to get rid of it, I would have to do the opposite.
Or the inverse.
Or the inverse, another I word.
Mm-hmm.
We might need to
keep a
inverse,
running list.
Isolate. Okay. Okay, so what would be the inverse of adding 3?
Subtracting 3.
Very good. So, if subtracting 3. So, if you had a twin, Trevor.
A twin, Trevor.
And if you got subtracted 3 and your twin over here didn't get subtracted 3, do you think you would be happy with what happened with you and not your twin?
No.
No. And so in equations, we have to keep it equal. So if I subtract 3 on this side of the equal sign, what do you think I need to do over here?
Subtract 3 to my twin.
Subtract 3 to your twin. Okay. Now if I add 3 and subtract 3, that will give me what quantity?
0.
0. So a lot of teachers sometimes say it cancels out.
Mm-hmm.
And it does because it is 0. Now, what is 18 subtract 3?
15.
15. All right. Now we're going to rewrite everything that we're still working with. We still have 5x. So 5x is equal to 15. So this is saying, 5 times some number is equal to 15. If I have mastered my multiplication facts, that would be very, very simple.
Mm-hmm.
If I haven't quite mastered them, or if I have a more challenging problem, we have a standard process that we go through in order to solve this equation. And I think you mentioned it at the very, very beginning. What do I need to do to solve this now?
Divide by 5.
Divide by 5. Okay, so 5x divided by 5. And your twin over here, what do you think should happen?
Divide by 5.
Divide by 5. So it's now balanced. It's equal. We've done the same thing to both sides. We've kept our equation balanced. So, a really tough problem. What's 5 divided by 5?
X.
5 divided by 5 will give me
1.
1. So, even though I have 5 divided by 5, it is equal to 1. So now, instead of having 5 x's, I only have 1 x. Okay? And again, teachers sometimes say that the 5's cancel out, but when we're adding and subtracting, it cancels to 0, but when we're dividing, it cancels to 1. And so I'm going to do the same thing over here. 15 divided by 5 equals
3.
3. So now I know, according to my equation, x is equal to 3. And depending upon the level of mathematics you're working with, just because it says x is equal to 3, I have to find out whether that I have one solution, an infinite number of solution, or no solution. Because when I replace my x back into my equation, do I indeed get a true statement? So after we've done all of our work, we have to go back and check. So now I'm going to put 5 times 3 plus 3 to see if it indeed equals 18. Okay, so help me out. What's 5 times 3?
15.
15 plus 3 equals 18. What's 15 plus 3?
18.
18. Does 18 equal 18?
I'm pretty sure.
Yes, it does. The twins have met. They are identical twins, not fraternal, but identical. They look just alike. 18 looks like 18. So indeed, this is a correct solution. Okay, does that help, Trevor?
Yes, thank you.
Trevor, you did an excellent job working with Ms. Davis today.
Yes, thank you so much. It was a pleasure to help you, Trevor. Now, did you want to try one of our challenges?
No, thank you.
No, thank you. Okay, well, we have challenges waiting. For any of our callers who would like to give us a call to get help with your math homework, the number is 301-772-0080. Even if we have listeners down by the riverside, you are welcome to call as well. We're here waiting to help you with any math homework that you might have.
Yep.
Now, in Prince George's County, a lot of the students were given winter break packets to help them review in preparation for our FAST testing, which is our countywide testing. So some of the students might have had some questions with some of those problems. Ms. McCants, which question do you think they might have had?
Well, I looked through the packet and simplifying exponents.
Simplifying exponents.
I found one that I think they may have.
And what exactly did it look like, Ms. McCants?
Sure, it was simplify -4.
-4.
Cubed, or to the third power. That's
Cubed
in parentheses.
In parentheses.
No, the 3 is outside.
Oh, the 3 is out. Excuse me. Okay, and you know what's so critical when you're simplifying a problem or just writing math problems is the notation. In mathematics, we have different symbols that represent different
things,
quantities or operations, and so this outside of the parentheses has a different meaning than if it was just -4 and the 3 the exact same size. So even though both of these involve parentheses and a 3, this has a different meaning from this right here. Okay.
So we have that times.
Okay, so -4 to the third power times
another -4 to the 7th power.
Another -4 to the 7th power.
And we did something similar to this a few weeks ago.
Yes, we did. Now, Ms. McCants, for the students who aren't quite sure why these parentheses are here, sometimes they've associated parentheses with multiplication, but in this case, the parentheses are drawing our attention to the fact that this is a negative sign. So sometimes there are more than one number in the problem, and so we would draw attention that this is a negative sign as opposed to subtraction. Okay, so very quickly, and then we'll take Denisha, or should we take Denisha and come back to this?
Let's take Denisha and we'll come back to this one.
Okay, all right. Okay, and it is and we'll change it to simplify in just a second. Okay.
Hi, Denisha. How are you?
I'm fine.
What school are you calling from?
Stephen Decatur.
Stephen Decatur? You have made Miss Davis's day.
All right.
So I see that you're working on solving equations.
Yes.
Okay, can you tell me the problem?
7x plus 4 equals 32.
7x plus 4 equals 32.
And I'm going to be the writer this time, and Miss McCants will walk you through.
And did Miss Davis write this down correctly? Denisha?
Oh, yes.
She wrote it down okay?
Yeah.
Okay, so I'm looking here, and so I'm looking here at the problem, and I'm noticing that you have a 7x here, right?
Yes.
And what are we doing with this variable? When we're solving equations, what are we actually solving for?
The variable.
We're solving for that variable. Okay, and you said that we're going to add 4?
Yeah, no, you don't add. You subtract 7, right?
You have 7x plus 4 equals 32.
Mm-hmm.
So the first step, because I see that we have a couple of different operations going on. I see multiplication and I also see addition.
Mm-hmm.
And we're trying to isolate the variable like we did with Trevor.
Okay.
Okay, so what we have to do first is our inverse of which one, the multiplication or the addition?
The addition.
Okay, so what is the inverse operation of addition?
Subtraction.
Subtraction. Okay, excellent job. So we're going to subtract. And just like Ms. Davis said, we're going to keep these equal on both sides or keep them balanced. So if I subtract 4 on one side, what do I have to do to the other side?
Subtract 4.
Subtract 4. Okay, so what is 32 take away 4?
28.
28. Excellent job. And what happens when I have 4 and I take away 4?
0.
0. I have a 0. And sometimes we call them 0 pairs. So now we're going to bring down our 7x and our equal sign. And so I now have 7x equals 28. What should I do now to isolate the variable, to get the variable by itself?
Divide by 7.
Divide by 7. Am I going to do that on both sides?
Yes.
Okay. So what happens here? I have 7 divided by 7. What's left over?
X.
1x. 1x. Excellent job. So now I have 28 divided by 7. And what does that equal?
4.
4. So x equals 4. Now, can I check this to make sure that we did the right job?
Yes.
Okay, and how do we do that?
Plug in an x.
Plug in the x where?
Behind the 7.
So we're going to put 4 in place of the x. So it'll be 7 times 4
plus 4
plus 4
equals 32.
Equals 32.
Oh.
Okay, so let's try it out. What's 7 times 4?
28.
28 plus 4?
32.
32. So 32 does equal 32. We have the identical twins, as Miss Davis liked to call them. Excellent job, Denisha. And thank you so much for calling from Stephen Decatur. Miss Davis is beaming and smiling all over the place.
All of the middle schools in Prince George's County.
Yes,
we are
yes,
challenging you to get help with your math homework this afternoon. All right, Denisha, thank you so much.
Denisha, your name is going into our treasure chest
for a chance to win a fabulous prize at the end of the show. Now, Denisha, are you familiar with 24 Challenge?
No.
No? Well, let me show you how simple it is, Denisha. Take just a few moments to jot these down, and you can give us a call back if you don't have a solution right this moment. But I want you to think about it. Which of these sets of numbers do you like?
B.
Which one? A, B, C, or D?
B.
B as in boy. So I have 2, 8, 7, 2. Now I want to use all 4 of these numbers so that I can get a total of 24. I can add, subtract, multiply, or divide, or any combination of those to get a total of 24. Okay? So but you have to use all of the numbers, and your final total, once you've used all of the numbers, equals 24. So do you want to jot those down and think about it? And give us a call back?
Okay.
All right. And guess what, Denisha? If you get the answer right, your name goes into the apple
2
twice.
times.
So the first time for calling and the second time for meeting the challenge. So you will increase your chance for a fabulous prize.
And if we don't talk to you again, Denisha, thank you so much for calling, and you have a good night.
Oh, Denisha, we forgot to allow you to represent your math teacher. Who's your math teacher at Stephen Decatur? Who? Miss... Who's your math teacher?
Miss Davis.
Well, please tell your math teacher we said a big hello from Count on Us. All right. We have had some callers that are getting the solving equations organized. And solving equations is something that students will continue to work with throughout their mathematics career.
Yes.
So getting a very, very good foundation with solving equations is very, very helpful. And we do have another caller that wants to solve an equation as well. I do believe they're calling from Walker Mill. We haven't had a Walker Mill caller today. Okay, so we'll go ahead and... Can you say your name for me, please?
Kaylani.
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 That's a pretty name.
It's such a wonderful
I
name.
love your name.
Kaylani, and would you like to give a shout out to your math teacher in your math class?
Yes, my math teacher name is Miss Johnson.
Miss Johnson.
Yay! Miss Johnson and the students at Walker Mill. All right, and you're solving equations?
Yes.
All right, so did you see the problem that we worked out with Trevor and...
Denisha?
Yes.
All right. And so is your problem similar?
A little bit.
A little bit similar. Okay. Well, we're going to use some of the strategies that we worked with Trevor and Denisha to solve this particular problem, okay?
Okay.
All right. So I will write it down, and Miss McCants and I will assist you to the best of our ability.
Okay.
All right. So go ahead and give me your problem, please.
Okay. It's 21.
21.
Parentheses 2 minus x.
Okay.
And then plus 12x.
Plus 12x.
Equals 44.
Equals 44. And Delani?
Kaylani.
Kaylani. Did I say it correctly?
Yes.
Okay. Kaylani.
Yes.
You're right. This problem is similar, but it's a little bit differently. But some of the basic principles that we use with solving equations, we're still going to apply them with this particular problem. There's just a couple extra steps involved. Okay?
Okay.
All right. So come with me and help me out. What do you know would be something that we would need to do for solving this particular problem?
First, you have to put a 1 by the x that's in the parentheses.
A 1 by the x, because anytime there is no number associated with it, it is understood to be 1. So when we canceled out our variables, our numbers before, our coefficients, we ended up with 1x. So we can go back and put that there. Okay, anything else?
I think you do distributive property 21 times 2.
I love your terms. Distributive property.
Okay, we are going to distribute or share this 21 with everything that's inside of the parentheses. Okay, because we're trying to think of what value of x can I substitute in when I finish working this out that I'm going to get a total of 44. All right, so how does this distributive property work?
Okay, so you multiply 21 times each number in parentheses.
Excellent. So I can put a multiplication sign here?
Yes.
And since we're using x's, I'm going to use a raised dot. Is that okay with you?
Yes.
All right. So what is 21 times 2?
42.
Okay, very good. 42 minus, what's 21 times 1?
21.
21. And I still have my x, so do I keep it or get rid of it?
You keep it.
Very good. So I have 42 minus 21x and I'm going to write everything that I haven't used, okay?
Okay.
Okay, so that would be plus 12x is equal to 44. All right. What do you notice now, Kaylani?
Then now you got two x's by both numbers.
Okay. And do you know what we refer to these as? Are they do they have the same variable? Are they alike?
Yes, they have the same variable.
And so we call them like
terms.
Excellent job.
Combine like terms, I think.
Combining the like terms. Excellent job.
So we need to combine the like terms. Now, I have negative 21, or subtracting 21, plus positive 12, or adding 12. What do I do when I have a positive and a negative? How do I combine those?
Do you remember our integer rules?
I think you subtract.
Okay, so we're going to find the difference.
Yes.
Okay, so if I think 21, negative 21, plus positive 12, and how much would that give me?
I think that, let me see.
Okay, so we can regroup if we need to.
Okay, so you make the 1 a 11.
11. So 11 minus 2 is?
9.
9. Now, is this 9 going to be positive or negative?
Negative.
And why do you say negative?
Because a negative plus a positive equals a negative.
In some cases, not in every case.
Do you remember the rule about the absolute value?
No, I don't remember that one.
Okay, so it's going to take on a negative sign because of the greater absolute value. Which number has the greater absolute value? Which one is
12.
Which one is furthest away from 0?
Negative 21.
Okay, and that's the reason why we're going to take the negative sign, because it's the furthest away from 0.
Okay.
Or, Keelani, if this helps you out and you don't remember absolute value, which do I have more of? More negatives or more positives?
You got more, I think you have more positives.
Okay, I have 21 negatives and 12 positives. Which do I have more of?
Oh, more negatives.
More negatives. So since I have more negatives, my answer will be negative. So you can take the absolute value and give it the absolute value of the integer that has the greatest absolute value, or you can think, which one do I have more of? Okay, so we did that to find out that we now have negative x, negative 9x. So I have 42. I can either think plus negative 9x, or I can think minus 9x. Both of those mean the same. Which one makes more sense to you?
Plus.
Plus a negative 9x?
Yeah.
Okay. Okay, so 42 plus a negative 9x
is
equal to 44.
Yes.
Okay, so we're still trying to figure out what value of x can I replace with this and multiply times negative 9 and end up with 44. Okay? So
I think you have to. I think. Do you subtract 44 from 42?
I'm going to
subtract the 42 from the 44.
Okay, so we're going to subtract 42, and we're going to keep it balanced. Subtract 42 from both sides.
Yes.
Okay.
And this is where it's similar to the other equations that we were working on earlier.
Okay, so 42 subtract 42 will give us 0. So I'm left with negative 9x is equal to 42 minus, 44 minus 42?
Equals 2.
Equals 2. Is that positive or negative?
Positive.
Why?
Because 44 and 42 are both positive numbers.
Okay. Yes, they were. All right. Okay, so I have negative 9x is equal to 2. How can I figure out the value of what x is?
You divide
by
9, negative 9.
Divide by negative 9. So negative 9 here, negative 9 here. Okay, what is negative 9 divided by negative 9?
1. 1.
1, excellent. And remember how you told me I could put a 1 right here next to the x?
Yes.
It's understood. So now that I did -9 divided by -9, I still have that 1x. It's understood to be 1x. And most times we just say x is equal to, but it's really 1x is equal to.
Okay.
And what does 1x equal?
1x equals 2/9.
Okay. Is it positive or negative?
-9.
Okay, so I have 2 divided by -9, but if I have a positive divided by a negative, what type of answer will that give me?
I think you'll get a decimal, I think.
If I actually divide it, I could come up with a decimal. But even though the negative is with the 9, this entire fraction is considered negative. So whether the negative is with the 9 or the negative is with the 2, it will be considered negative. But if I had 2 negatives, it would be positive. But since I just have 1, x is equal to -9.
Okay.
2/9.
I'm sorry, x is equal to -2/9.
Okay.
Okay, does that help?
Yes.
Okay.
Thank you.
Keilani, you did a great job.
And Keilani, I'm putting your name
is going into our
treasure chest.
Because we treasure all of our callers.
Yes, we do.
Here at Count on Us. And we have one more caller,
But
Tori.
we're going to take a break.
Tori, do you have a couple minutes? Can you join us on the other side of the break, or you need help right this second? Tori, we're going to ask you to hold on.
Please continue to hold. Please continue to hold.
And join us on the other side of the break.
We'll be right back.
Hi, I'm James. I'm from Tilton Elementary School. I'm here today for the email question of the day. Mary needed to place a fence in her yard in order to keep her sheep in. If her yard is a rectangle with a length of 26 feet and a width of 20 feet, how much fencing will she need? Well, let's take a look. So first, I would draw a rectangle to represent her feet. Then I would draw 26 feet at one side and 26 feet on the opposite side. Then I would draw 20 feet at one and another side, and then 20 at the opposite side to represent the fencing. Since we're talking about perimeter, since I have to do perimeter, I have to add all the numbers. 26 plus 26 plus 20 plus 20. 6 plus 6 equals 12, so I'll put the 2 at the bottom and carry the 1. 2 plus 2 plus 2 plus 2 equals 8. Then I'll add the 1. That equals 92 feet. So the fencing of her yard will be 92 feet. That's it for the email question of the day. Stay tuned for some more on Count on Us.
At this moment, across the country, families are packing their bags for a getaway. And no matter where they end up, they'll all be home by dinner. Plan your own at playgolfamerica.com. From finding programs in your area to finding advice from PGA professionals, playgolfamerica.com has a way for you to get away. Visit today for details. playgolfamerica.com, your link to the game.
It's easy, Grandpa. Brush your teeth twice a day. Floss your teeth once a day. That's the way to fight decay. Hey, hey. Brush and floss every day. Hey, hey. Healthy smiles are the way. Hey, hey.
You can keep your smile for a lifetime. Even a boomersaurus like me.
Boomers, you gotta love them.
Welcome back second half of your Telly Award-winning math homework hotline. I'm Mrs. Davis here with my fabulous partner.
I'm Miss McCants.
We're here to help you with any math homework that you might be having. Not reading or science, unfortunately, just the numbers bit. So we're here to help you with any math homework that you may be having. You can give us a call at 301-772-0080. We're here waiting to help you.
Yes.
And we really appreciate all of our callers that have called in so far. They've been working to solve equations. And Tori has been so very, very patient. So Tori, without further ado, I believe we're going to help you solve an equation as well. Is that correct, Tori?
Yes.
Tori?
She said yes.
Oh, okay. And Tori, is there a particular school you want to give a shout out to?
Gwen Park Middle School.
Gwen Park Middle School! Yay!
2-1. 2-1. 2-1. 2-1.
Glen Park representing.
Thank you.
As well as Walker Mill and Stephen Decatur representing. Okay, we are still solving equations. And as we mentioned earlier in the show, solving equations and integers is one of the foundational things that you will be using in mathematics from this point on. Next to knowing your basic facts, adding, subtracting, multiplying, and dividing. So you have to know those quick, quick, quick. All right, so I'm going to write, and Miss McCants will help you with the problem. So Tori, which equation would you like to solve?
I'd like to solve 2x plus 6 equals 12.
2x plus 6 equals 12.
Okay.
Okay, so Tori, when we're looking at equations, what's the first thing that we need to do?
Get x by itself.
We're going to get x by itself. So how do we do that? I'm looking here and I see two operations going on. What are the two operations?
Addition and multiplication.
Addition and multiplication. Okay, so what is the inverse operations of those two things?
Subtraction and division.
Subtraction and division. So the first thing we're going to do is try to get rid of which part? The addition part first or the multiplication?
I think the addition part goes first.
Okay, so what inverse operation will we use to get rid of plus 6?
You would subtract it.
Subtract what?
Subtract 6.
Excellent job. From
12.
From 12. So we're going to subtract 6 from 6, and we're going to subtract 6 from 12. Is that correct?
Yes.
Okay, great. So once we have identified what is left over on this side of the equation. 6 take away 6 is
0.
0. Okay, excellent job. And now I have 12 take away 6, which is how much?
6.
6. Excellent job. So I'm going to, now Ms. Davis wrote down 2x equals 6. What is the next thing we need to do? What is the inverse operation of 2x?
You divide by 2.
We're going to divide by 2, and we're going to make sure that we keep it equal or balanced by dividing by 2 on the other side of the equation as well, right?
Yes.
Okay, excellent job. And now what is 2 divided into 2?
1.
1. And so that leaves me with 1x, correct?
Yes.
Okay, and what's 6 divided by 2?
3.
3. Excellent job. Now, can we check to make sure that we solve correctly for x?
Yes, by putting 3 into the original problem.
Okay, putting 3 into the original problem. So I have 2 times 3 plus 6 equals 12. Correct?
Yes.
Okay, so now what's 2 times 3?
6.
6. 6 plus 6 equals?
12.
12. So now I have 12 equals 12, and that does check. Excellent job, Tori. Excellent job. Thank you for calling.
Now, Tori, we didn't put the challenges up right before you called in, but we'd like to put them here now in case you would like to challenge yourself with the 24 challenge. Tori, are you familiar with the 24 challenges?
No, I am not.
Well, let me just explain. It will only take a second. 1 second and then a couple minutes of thinking and brain power. Okay. We have one caller who is working to find a solution for card B. So if we'll take a look at card B, it has the numbers 2, 8, 7, and 2. The other cards are 6, 9, 1, 8. That's card A. Card C is 1, 2, 9, 6. Card D, 4, 9, 4, and 8. Now the way that this works, Tori, is we want to use all 4 numbers here, all 4 digits, so that we get a total of 24. And guess what, Tori? We can add, we can subtract, we can multiply, or we can divide, or we can use a combination of all 4 of those. Okay?
Okay.
Now, which of these cards do you include some of your favorite numbers that you would like to try to see if you can come up with a total of 24?
B.
B as in boy, or C as in cat?
C as in cat.
C as in cat. Okay, so 1, 2, and this, when it's shaded in red, this is a 9, and when it's unshaded, it's a 6. Okay, so do you want to try right now, or you want to give yourself a minute or two think time and give us a call back with the solution?
I could try to figure it out now.
I'm glad she is up for the challenge. She is up for the challenge.
We are talking about. Okay, so Tori, we're going to list the numbers now. So we'll have 1, 2, 6, and 9. And remember, we can add, subtract, multiply, or divide. But when we are finished, voila, we want the total to be 24. And so there is the 24 challenge. Okay, Tori, guess what? Your name will go in a second time for a chance for a fabulous prize.
Right now for the first
because
time.
We treasure all of our callers. And so we'll treasure you even more for completing one of our challenges. Okay, Tori, what did you have in mind that's going to kind of help us to get to 24?
I was thinking you could multiply 2 times 6.
You want to do 2 times 6?
Yeah, and get 12.
Okay, 2 times 6 does indeed equal 12. So we've used the 2 and the 6, and we have to use the 1 and the 9, and we can also use this 12 so that we get a total of 24. Okay, now once we've used a number, we can't use it again. Okay, I didn't say that, but once we've used it, it's finished. Okay, so 2 times 6 is 12.
I was thinking then you add the 9 and the 1, which would be 22, but that doesn't get 24.
No,
okay,
not
so we
quite.
can add 9. So we can have 12 plus 9, which will give us 21. And then we would add 21 plus the 1. So we are very
close.
Very close.
Now I'm thinking maybe if you multiply 2 and 9, you can get 19.
Well, let's try that.
2 and 9.
I like that.
I think she's on the right track. I think
okay, I'm gonna rewrite them.
Yes.
And you know what? The good thing about math is it's okay to come up with an incorrect solution.
6, 9.
Because it just makes you think.
9.
And and it just makes you think. That didn't work. Let me see if I can try something else. Okay, Tori, we're here ready and waiting. I think you're on to something.
I think you are too. So you started out by saying 2 times 9.
Okay, so 2 times 9.
I love it. I love it.
Equals how much?
18.
18.
So we've used the 2 and the 9.
Girl, you are
trying
hot.
to get to 24. What you
You are
think?
real close. I love it.
I added 6 to that.
Okay, so 18 plus 6
is 24.
18 plus 6 is 24.
Excellent job, Tori.
The only thing that's holding us up, Tori, we got to use every single number.
So what are we going to do?
What should we do with that 1? What should we do with that 1, Tori?
I multiplied 24 times 1.
Yes, ring the bell.
Tori, you've met the challenge.
I love it.
So 24, 1 times 24. And Tori, I am going to challenge you even more. In mathematics, when we multiply by 1, there is a property or a rule. Do you happen to remember that? Or have you ever heard of that property? When you multiply by 1?
I think I've heard it before.
Yes.
I think you may have.
I think you have too.
Now, I don't know if I can spell it right.
Identity.
I-D-E-N-T-I-T-Y. The identity, property of, and what were we doing right now?
Multiplication.
Okay, guess what? You are absolutely...
This girl is on fire today.
Girl is... don't make me sing.
Oh, no, don't make her sing. Please don't make her sing.
Sometimes I've been accused of singing like my daughter. My daughter has a wonderful voice.
Oh, why did you have to bring Jasmine into this?
All right, so guess what, Tori? Your name is going into the the treasure chest.
For the second time.
For the second time. So, Tori, please stay tuned at the end of the show to see if you are indeed a winner. And we did have another person that was going to try a challenge.
Denisha, I think.
So if she would like to try a challenge, it's as simple as what Tori has shown us. So we'll stick those up one more time in case there's some callers that are
put it right back.
Out there wanting to challenge themselves with a 24 challenge. Card A, 6918. Card B, 8722. Card C, 96. And Tori has already given us a solution for that one. So if you call in, you would need to give us a different solution. And the great thing about 24 Challenge, there are multiple solutions for each of these cards. And card D is 4, 9, 4, and 8. Okay? So take a few moments to jot those down, and you can give us a call to challenge yourself with our 24 Challenge. In the last couple of minutes in the show, Miss McCants?
Yes, we were working on a problem.
Yes. For those of you who have tuned in for the entire time, we're gonna rewind kind of and go back.
And we went ahead and finished spelling out the word simplify.
Simplify. So okay. Every time I spell something, I need a caller to call in to verify that I've spelled it correctly. See, I just throw those in there. I misspell things at no additional charge.
No additional charge.
No additional charge for misspelling things. So you have to watch me very carefully. Make sure everything I put up is spelled correctly. And we are trying to simplify. These are exponents.
That's right.
Okay. Miss McCants?
Yes.
What in the world do you do with these?
Well, I'm noticing that they have
little numbers, parentheses, minuses, dots, and
actually, these aren't minuses because they're representing that these numbers are negatives.
Oh, so those are negatives.
These are negatives, and also I'm noticing that they're the same.
Oh,
they're the same negative. So that base number is going to stay the same. I think what we need to concentrate on are the exponents.
Oh, so the big number is the base?
Big number is the base. B for B.
B for big and B for base. Oh, I like that. I think that's going to help me remember. The big number is the base.
That's right.
And these are twins. They
match. They are matching.
Okay.
Here we go with those twins again.
Twins just seem to be everywhere today.
Twins are everywhere. Watch out. You may see them.
Okay, so these are our bases.
That's right.
Okay, and so when we're simplifying exponents, if we have the same base, the same big number, that will help us simplify?
Yes, it will. Because now we don't have to concentrate on those base numbers. We can keep the base number the same. We're going to look at the operation that's going on.
So I can keep this -4. Is that what you're telling me?
That's what I'm telling you.
Okay.
So I'm looking at it and I see now that we have multiplication. When we're dealing with exponents, we're going to concentrate on the 3 and the 7, and our operation for those exponents are going to be addition.
Now, what exactly does this exponent mean?
That means that we're going to write this 4 out 3 times.
What?
Yes, we're going to write the 4 out 3 times.
Oh, so do I add it 3 times? Multiply it 3 times?
Multiply it 3 times because our operations.
Oh, so this is like -4 times negative.
Okay,
so that's 3 times.
When we have exponents with a base number, they're actually telling us our operation is a given. Always, we're going to multiply.
Always multiply. So this means multiply. So if I'm tired or I just want to do shorthand and or my wrist is hurting, instead of putting -4 times -4 times -4, I can just put do I say this, though?
You could say -4 to the third power, or you can also say -4 cubed.
Oh, okay, I like that. Well, wait a minute. So I have -4 here as well.
Yes.
So that means I'm gonna have some more -4s?
You are going to have some more -4s. You're going to have 7 more -4s.
7 more. Okay,
with the operation of multiplication.
Okay, so let me try. Okay, so those are for right there. Maybe I should have written them a little smaller. Maybe I can squeeze them in. So that's 1. Okay, keep counting for me out there. That's 3. That's 4.
And that's it. Oh, I'm sorry.
No,
7. You're going 7.
I gotta keep going.
You gotta keep
so
going.
That's 4.
We add it to the front side.
I'm gonna put them over here, so we'll know that the green ones go with
the 7.
Okay, so that's 5. That's 6.
And
that's
7.
Okay. And I'm gonna put a time sign. All right.
And don't forget your negative.
And I need my negative.
Okay.
All right. So
Can we count the green ones again?
Okay, let's count the green ones to be sure.
1, 2, 3, 4.
5, 6, 7.
Okay.
So I have -4 7 times. And I have -4 3 times.
Yes.
Okay, so are we done?
We are not done. Now we have to add all of the -4s that we see together.
Oh, so count them up.
Just count them up.
Okay, count them up. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
So now we're going to simplify. This is where the simplification comes in.
Okay, so
because
this
we don't
this didn't look simple at all.
That's a lot of work there.
That's a lot of work. Okay, so now I'm going to simplify. Okay, so how do I simplify?
So you can put your parentheses, your open parentheses.
Okay.
-4, close parentheses.
Now, wait a minute. I'm thinking of something. Now, you said that if I have my base, my big number, it tells me how many times I multiply my exponent. Okay, let me think. Now, I saw a -4. I have all -4s here, so I'm going to keep that the same.
That's going to stay the same.
Now, if I
There's
count
a shorter
carefully,
way.
if I count carefully, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yes.
So this would be -4 to the 10th power.
Miss Davis, that is excellent, but we could have done this a shorter way.
A shorter way?
There's a shorter way.
A shorter way.
We didn't need to write all of these numbers out.
Okay, okay. And I like shorter ways.
I know.
Math, there are multiple ways to do math.
To come up with the same answer.
Okay, so what do we do? I'm going to rewrite the problem, and what are you going to tell me about now?
I'm going to tell you that if we have the same basis and our operation is multiplication with the different exponents, we can write -4.
Oh, -4. Because that's our base.
That's
I remember.
our base.
That's
the big number. That's going to stay the same. And I'm going to write a 3.
Because I got it from right here.
Plus 7.
Plus 7.
Yes.
Oh, because I had 3 right here. Those were the blue ones.
That's right.
And then I had the 7 green ones. -4 to the 3 plus 7. Hey! I know what 3 plus 4 is. It is 10. So, hey, this exact same thing. And we have simplified. All right.
High five.
Woo! All right. We thank you so much for joining us here at your Telly Award-winning Math Homework Hotline. And we treasure all of our callers, but there's one caller in particular who has called in and will be receiving a fabulous prize.
Kaylani from Walker Mill.
Kaylani from Walker Mill. We really, really appreciate you, Kaylani, and all of our callers. And remember, each Monday and Wednesday, you can join us here at your Telly Award-winning Math Homework Hotline because you can always
count on us.